The last part of the section is just something that I can make you aware of that might make taking integrals easier on you if you recognize this. But what we have here is integration of odd and even functions. It says let f be integratable on a closed interval from -1 to a. All right. And it says if we have an even function and it goes from -a to a, so that's got to be the same number. Maybe so it's the same distance away from 0 is what it's saying. So maybe it goes from -1 to 1, or if it goes from -2 to 2. Regardless, these have to be the same number. One's negative, one's positive. Okay? If it's an even function, we can just evaluate it on one side of the y-axis. So if we have a graph, we can just evaluate it on this side, all right, of the y-axis. And it just might make it easier to go ahead and evaluate that integral. All right, and all we do is we bring a 2 out in front and put that out in front if it's an even function. Okay, if it's an odd function, the nice part is it's going to, as long as it goes, again, this is from a -a to a +a. If it's an odd function, the nice thing is the integral is going to be 0, because if we think about what an odd function looks like, if you think about like we know that, you know, x to the third power is an odd function. Well, the area here, and say we go from the same number, I don't know, from 1 to -1, say this is 1 and this is -1, all right? Well, if you think about it, we'd evaluate this area, figure this area out, be some positive value, and then we'd figure this out, well, it's going to be some negative value. So you think when you add those two together, or you subtract those, all right, or sorry, I misspoke there. You're gonna, yeah, when you subtract them, they're gonna cancel out. Okay, so what's gonna happen then is if we recognize that's an odd function, it goes from the same number, so like a -1 or a -2 to a +1 or a +2, whatever it is, or whatever. Okay, it's going to be 0. We don't have to mess around with taking the integral. Okay, so one example I can show you that may look like a tough example, but it's really going to turn out to be fairly simple. We just need to determine whether it's an odd or an even function. Notice that my upper limit here is pi over 2. My bottom limit is -pi over 2. So this might throw you into a, you know, maybe it's a clue that we should check something out before we go to the trouble of taking the integral of all this stuff. Well, first of all, we need to remember what a non-even function is. If you remember, if we have an even function, if we have f of x and we plug in f of -x, all right, they should equal each other. All right, so when I plug in -x, there would be no sign changes, nothing. It'll be exactly the same. So like an example of an even function is f of x equal to x squared. If I were to plug -x into that function, I'm going to get x squared. That's an even function. What an odd function is then, so this is even. What an odd function is when I plug -x into there, I'm going to get a negative f of x. Okay, so that means every single sign is gonna be different. So just a simple example, like I used up above, x cubed graph, all right, is an odd function because when I plug negative x cubed into here, anything cubed is still going to be negative. I'm going to have negative x cubed. So I have the opposite sign of what I have up here. So that's an odd function, all right? So let's think about this. Let's find out whether it's an even or an odd. So basically, we just plug in -x and see what we find out. One little hint here that you might not remember or realize last year that cosine is an even function and sine is an odd function. All right. So what we do here is we plug -x in for sine. So sine of -x cubed cosine of -x plus sine of -x cosine of -x. All right. Well, we said sine is an odd function, so we got a -x is going to be an odd, so we're going to have a negative sign, and since it's cubed, it's still going to be negative, so I'm going to have negative sine of x. All right. And then cosine of -x, we said cosine is an even function, so that's just going to regularly be cosine of x. Okay. Then again, we said sine was an odd function, so that's going to be negative sine x. And cosine is an even function, so this is going to be cosine of x. All right. If you were notice from our original equation here, the signs are completely opposite. So therefore, our f of negative x, or f of x. All right, so when we plug f of negative x, we're going to get negative f of x. Therefore, it's a odd function. Since this is an odd function, we can use what we just found out from that theorem up above, that we don't even have to mess around with taking this derivative. Or, I mean, integral, sorry. We don't have to mess around with it. It's going to be 0, no matter what. So, turned out to be something pretty simple. So, another thing for you to look for that might make life of taking integrals a little bit easier. See you in class.